Imagine a world where entire oceans begin to freeze, where glaciers stretch across continents, and where the survival of life itself hangs by a thread. At least once in Earth's history, the planet may have transformed into a frozen sphere, ice reaching from the poles all the way to the equator. Scientists call it Snowball Earth. But how could an entire planet freeze solid? And more importantly, how did life survive? Because the Ice Age is not just a story about cold temperatures, it is a story about extinction, survival, and the fragile balance that allows life to exist at all. Nearly 99% of every species that has ever lived on Earth is now extinct. Many vanished during violent climate upheavals that reshaped the planet again and again. The Ice Age was one of the most powerful of these forces. To understand it, scientists often compress Earth's 4.5 billion year history into a single day. In that scale, life appears late in the evening. Complex organisms arrive just minutes before midnight. But long before humans existed, the planet had already endured extreme climate catastrophes that nearly erased life entirely. One of the most dramatic events occurred roughly 650 million years ago. Geological evidence suggests Earth may have entered a phase of almost complete global freezing. Instead of polar ice caps in temperate zones, glaciers spread across oceans and continents alike. Ice may have extended thousands of kilometers, reaching regions that today lie close to the equator. For decades, scientists struggled to understand how such an extreme event could even be possible. After all, Earth receives enormous energy from the Sun. A total planetary freeze seemed almost impossible. Yet, strange geological clues began appearing in rock layers scattered across the globe. These clues came in the form of mysterious stones known as drop stones. Massive rocks embedded inside fine layers of sediment where they simply should not exist. In calm ocean environments, heavy stones cannot normally appear in the middle of delicate sediments. Something extraordinary had to transport them there. The answer turned out to be ice. When glaciers advance across land, they act like enormous bulldozers. They grind mountains into dust, pick up massive boulders and drag them across landscapes for thousands of kilometers. When glaciers eventually melt over oceans, those stones fall into the seabed, creating the strange drop stones that geologists later discover millions of years later. But here is the unsettling detail. Many of these drop stones were discovered in regions that were once near the equator. That means glaciers, normally confined to the poles, once existed in tropical environments. In other words, the evidence suggested something almost unimaginable. The Earth may have frozen nearly completely. Modern glaciers help scientists visualize how such immense ice systems behave. In places like Alaska or Antarctica today, glaciers move slowly, sometimes only a few meters per year. But over thousands of years, that slow motion reshapes entire continents, carving valleys, transporting debris, and grinding bedrock into fine powder. Yet the question remains, what could possibly push the entire planet into such an extreme frozen state? At first, scientists looked toward changes in Earth's orbit. Our planet's tilt and orbit fluctuate over tens of thousands of years. These cycles influence how much sunlight reaches different parts of the planet and are known to trigger smaller ice ages throughout Earth's history. But orbital shifts alone cannot explain a fully frozen planet. Something much more powerful must have amplified the cooling. The key appears to lie in the atmosphere, specifically in carbon dioxide. CO2 acts as a greenhouse gas, trapping heat in the atmosphere. When levels drop dramatically, the planet begins to cool. During the ancient Snowball Earth event, atmospheric carbon dioxide may have fallen to extremely low levels. Surprisingly, some of this carbon removal may have been caused by life itself. Ancient microorganisms called cyanobacteria were already thriving in Earth's oceans. These microscopic organisms perform photosynthesis, absorbing carbon dioxide and releasing oxygen. Over millions of years, they removed vast quantities of carbon from the atmosphere and locked it into limestone deposits on the seaboard. As CO2 levels declined, global temperatures slowly began to fall. Once ice began expanding from the poles, another powerful process accelerated the cooling. Ice reflects sunlight far more efficiently than oceans or land. Scientists call this the albedo effect. As glaciers spread, more sunlight bounced back into space instead of warming the planet. The result was a dangerous feedback loop. More ice reflected more sunlight. More reflection caused lower temperatures. Lower temperatures allowed ice to expand even further. Eventually, the planet reached a tipping point where this cycle spiraled out of control. Earth entered a frozen world. Yet something remarkable happened during this frozen era. Life did not disappear. Instead, it adapted. Beneath thick ice sheets, oceans remained liquid in some regions due to geothermal heat from the Earth's interior. In these hidden environments, microbial life continued to survive. Some organisms even lived inside the ice itself, occupying tiny pockets of liquid water. Modern scientists studying extreme environments have discovered organisms capable of surviving in similar conditions today. Inside Antarctic ice caves, researchers have found microbial communities living in complete darkness. These organisms do not rely on sunlight. Instead, they obtain energy directly from chemical reactions involving minerals and rocks, a process known as chemosynthesis. Such survival strategies may explain how life endured millions of years of planetary freezing. Because Snowball Earth did not last for centuries or even millennia, it may have lasted 25 million years. Eventually, another force began to reverse the freeze. Volcanoes across the planet continued erupting during this frozen era, releasing carbon dioxide into the atmosphere. Normally, rainfall and chemical reactions remove CO2 from the air, but with the planet locked in ice, those processes slowed dramatically. Carbon dioxide began accumulating. For millions of years, volcanic emissions built up in the atmosphere like pressure inside a sealed container. Gradually, the greenhouse effect intensified, temperatures began rising, and when the warming finally reached a critical threshold, the frozen planet began to melt. What followed may have been one of the most dramatic climate shifts in Earth's history. As glaciers retreated, massive floods of fresh water poured into the oceans. Atmospheric temperatures surged. The chemistry of the oceans changed rapidly. But perhaps the most important transformation occurred in the atmosphere itself. Oxygen levels began rising dramatically. Before this period, oxygen made up only a tiny fraction of Earth's atmosphere, around 1%. But after the Snowball Earth event, oxygen concentrations surged toward the 21% we experience today. This shift unlocked enormous biological potential. Higher oxygen levels allow organisms to produce far more energy inside their cells. That extra energy made complex life possible. Shortly after the frozen era ended, Earth experienced one of the most important evolutionary events ever recorded: the rise of multicellular life. Animals, plants, and complex ecosystems eventually emerged from those ancient oceans. In a strange way, one of the harshest climate catastrophes in Earth's history may have helped trigger the explosion of life that followed. But the story of ice shaping Earth did not end there. Hundreds of millions of years later, the planet entered a series of more recent ice ages that dramatically reshaped modern landscapes. During the last 2 million years, enormous glaciers expanded across North America, Europe, and parts of Asia. Some of these ice sheets were over a mile thick. Their immense weight crushed landscapes beneath them, grinding mountains into dust and carving enormous valleys. As they advanced and retreated, They reshaped rivers, altered ecosystems, and sculpted the geography we recognize today. One of the clearest examples can be found in North America. The Great Lakes, Superior, Michigan, Huron, Erie, and Ontario exist largely because of ancient glaciers. These massive ice sheets carved enormous basins into the bedrock. When the ice melted, the basins filled with water, creating the largest freshwater system on Earth. Glacial movement also left behind enormous boulders known as erratics. These rocks often appear in locations completely different from their geological origin. Some were transported hundreds of kilometers by slow-moving ice before being deposited when glaciers melted. Even the planet's crust responded to the weight of ice. In some regions, the enormous pressure pushed land downward. When the glaciers finally disappeared, the crust began slowly rebounding upward, a process still continuing today in parts of Canada and Scandinavia. Ice ages also reshaped global coastlines. During the coldest periods, so much water became locked inside glaciers that sea levels dropped dramatically. Entire land bridges appeared between continents, allowing animals and eventually humans to migrate into new territories. At one point during the last ice age, Florida was nearly 3 times larger than it is today. Vast coastal plains stretched far into what is now the Atlantic Ocean. These shifting landscapes changed migration patterns, ecosystems, and evolutionary pathways across the globe. The Ice Age also gave rise to some of the most extraordinary animals ever to walk the Earth. Woolly mammoths roamed the frozen plains. Giant ground sloths towered over forests. Armored mammals called glyptodons, relatives of modern armadillos, grew as large as small cars. This world of megafauna dominated Ice Age ecosystems for thousands of years. But toward the end of the last Ice Age, many of these giants vanished. The cause of their extinction remains one of science's great debates. Some researchers believe rapid climate warming destabilized their habitats. Others argue that expanding human populations hunted these animals to extinction. Many scientists suspect the truth lies somewhere in between. A combination of environmental change and human pressure may have pushed already vulnerable species beyond their limits, and that raises a disturbing possibility. Ice ages are not rare events in Earth's long history. They occur in cycles influenced by orbital mechanics, atmospheric chemistry, and geological processes. The frozen eras that shaped our world were not accidents. They were part of Earth's natural rhythm. Which leads to a final question scientists continue to investigate. If our planet has frozen before, if glaciers once covered continents and oceans, if climate has shifted so dramatically that entire ecosystems vanished, could it happen again? And if another ice age were to begin, would modern civilization be prepared to survive it? Because the history of Earth suggests something both humbling and unsettling. The climate that allows human civilization to exist may be far more fragile than we ever imagined.